The objective of this demonstration is to analyze the effect of crouching when riding a bicycle. To begin the exercise, click Create Solution and select Fluid Behavior. Leave the fluid material set to air and allow Discovery Live to create a fluid volume for external flow. Then click Create. Zoom out to get a better view of the enclosure indicated by the orange outline. Rotate the model slightly so that all 6 faces of the enclosure are clearly visible. In this simulation, the rider is going to be traveling forward, so let's select this face as the inlet for the airflow. The last thing we need to specify before we can see some results is a ground plane. The bottom face of the enclosure will be a good approximation for the road. Click this face to select it. Once we've defined these 2 items, Discovery Live begins to generate some results. Let's pause the simulation to make some adjustments to our boundary conditions. The boundary conditions can be found in the Solution panel on the left side of the window. Let's increase the flow velocity to 12 meters per second. That's about 27 miles per hour. Press H on the keyboard to go back to the home view. Move your mouse cursor to the slip symmetry condition and note that slip symmetry has been applied to 3 faces of the enclosure, but not the ground plane. For this simulation, that's okay. Reorient the model using the orientation tool by clicking the Y handle on the cube. Hold Shift and middle mouse click and drag to adjust the position. Now, let's go to the structure tree at the top right of the window and locate Enclosure in the list of components. Select the checkbox to clear it and hide the enclosure. Let's start our simulation again to view the results. As we can see, there's a large pocket of slow-moving air immediately behind the cyclist. This is caused by separation in the airflow as the air passes over the body of the cyclist. We can examine this further using streamlines. Pause the simulation and disable the display of results. Then click the Streamlines button to activate Streamlines. We need to make some adjustments here in the menu to see the results a little better. Click the Width slider and drag it to the left to reduce the width of the streamlines. Press the Start Animation button to see their behavior. We still have a fair number of streamlines passing to either side of the cyclist's body. Rotate the model so we can see the emitter, then click the emitter outline and drag towards the center until only one set of streamlines is being generated. Return to the side view and examine the results. Let's move the emitter up slightly so the streamlines are passing over the head and torso of the cyclist. Now that we've done this, we have a pretty good indication of where the airflow is separating just downstream of the cyclist. Let's go back to our surface velocity display by disabling the streamlines and enabling Show Results. Start the simulation again. We're now going to examine how a change in the position of the cyclist's body can affect the airflow. Let's create a calculator to calculate the drag force being exerted on the cyclist. We can create a calculator from the Solutions panel here on the left side of the screen. Click the Calculator button and give the calculator a name. In this case, we'll name it Drag. Select the correct direction from the list. The drag force will be parallel to the airflow, which is traveling in the X direction. For location type, choose All Faces of Body and leave the display type as Chart. Click Select, then click and drag a box around the entire cyclist. Click the check mark to complete the operation. Once we create the calculator, it begins to report some results. As you can see, there's a lot of fluctuation, but this is to be expected since the airflow is constantly moving. The value should fluctuate around an average. If we collapse the calculator graph using this icon here at the top left, we can report it as a single value. This makes it a little bit easier to read. Now, let's adjust the position of the rider's body. If you move the mouse cursor to the Groups icon, You'll notice that a driving dimension has already been created. Click Body Angle, then click the value and enter in a value of 25 degrees. Then press Enter. As we can see, the position of the rider has changed and the results have updated accordingly. The quantity reported for the drag is significantly lower than what it was for the rider in the upright position. Looking at the velocity profile, we can also see that the large blue pocket of slow-moving air behind the torso is no longer present. This means there's much less separation in the flow as the air passes over the rider. This concludes the demonstration on understanding the effect of crouching when riding a bicycle.